I don't know if you guys saw in the news about that polynomial tree that fell over. Yeah, I guess it didn't have any real roots. All right, mathletes, so let's look at these polynomial inequalities. And to help us wrap our minds about what we're doing, let's first look at this example right here. So say you just bought a stock, all right? So you just bought a stock, and of course what people do is they monitor how well their stock is doing. And it might, especially times like this, we're in 2020, we're in November now, and we can see the volatility. So this stock, the price is really moving around, all right? And the reason it's so choppy is because, again, in real life, these functions are choppy. They're sometimes they're not as nice as we want them to be. But here's the idea, all right? One thing we want to look at in this case is, when are we going to be making money? So we might want to look at, when is that price? In this case, this might represent the price. When are we earning money? So when is it above the x-axis? Or when are we losing money? And that's the big question. So when we're looking at, where did this stock, right, between what periods, after how many days was it in the red, and when was it in the green? When was it positive? When was it negative? So here, one thing we're going to be looking at is, when is it above the x-axis? And when we're looking at these inequalities, that's exactly what we're looking at. When is it above the x-axis? When is it below the x-axis? When is it a zero, right? When is that height zero? What does that height represent? So it's important that you understand all these questions. So here, let's say I'm interested in when the function is above the x-axis. When the function, right? When the function is greater than zero. So if we're looking at when it's greater than zero, we're strictly looking at when it's above zero. So here, we could see that's above zero, from 0 to 4. All right, so from 0 to 4, so from 0 to 4 there. But is that the only place? Well, no. And notice the notation I'm using. I use open parentheses here because I'm not including 4, because we want it to be strictly, where is it greater than 0? If it said greater than or equal to, then I would include that 4. So make sure you're aware of that, because notation is key. Well, notice it's also greater than 0 from 5 to 9 there. So we put a U, not me, but U, and then we go from 5 to 9. And again, because we're not looking at where it's equal to 0, we don't include those endpoints. So that's going to be another key thing for you to understand as we move forward here. And we could see that above past 13 days, it was positive. So we say from 13, and let's just pretend it went on for infinitely many days. Let me do that parenthesis one more time, and there we go. So this is what we're looking for. All right, so what's going to be key is you understanding, number one, am I looking for when the function is greater than 0 or below 0? If we're below 0, then we could see from 4 to 5, and then from 9 to 13 days. All right, so this is going to be the idea that we're looking at. And now we're going to put the math. What does the process look like? All right, so follow me so we can see what the process looks like. All right, so now let's look at the process when we're dealing with non-linear inequalities. And some people will see all these rules just like this, and they might get like scared, right? They might say, you know what, forget this. No. I'm going to break it down, and I'm going to put it in my own words, but using the same exact ideas, right? We're going to do it Dr. Math style. All right, so don't go anywhere. And if you haven't already, go ahead and destroy that like button, subscribe, and look what I got in store for you. All right, so first things first, all we do is we set one side equal to 0. So what we're going to look at is two different techniques. They're very similar, but today you're going to decide on which technique you want to use. All right, I like both. So first things first, move everything to one side, right? Get rid of those parentheses, distribute, and set one side to equal to 0. We're going to go through an example, all right? We're going to walk through an example, but first, here's the overview so you can see that it's not so bad. So we set one side equal to 0. That's step one, all right? Once your inequality has 0 on one side, right, because that's what we're comparing it to, you have to pay attention to, what are you looking for? Are you looking to see when this is greater than 0 or less than 0? Because that's going to determine your solution set. All right, in this case, look, it says, I want to know when is this less than 0. So if I were to graph this, I want to know where it's below the x-axis. All right, so that's important too. So the next thing we do, step 2, is we pretend that we're going to set this equal to 0 because we want to find these boundary points, right? These very important points. So we know where the function is going from negative to positive or positive to negative and vice versa. All right, so we set, step 2 is we set this inequality equal to 0, and that's going to help us find boundary points. So notice, in this case, I have to factor, so we factored, and now we're going to set each one of those factors. Let me just do one of them for you. That 3w minus 4, we're going to set it equal to 0. So we solve that, and again, when we solve this, this is the easy part. What this is going to give us is this is going to give us our boundary point. So that's how we get that 4/3. This is one of our boundary points, right? So that's where that 4/3 comes from. So all we do is set each one of these equal to 0. If I set this equal to 0, I have to subtract 1 from both sides, and that's where I get that -1. So these are your boundary points, and that's step 3. That's what you're looking for. Because now that you have those boundary points, those zeros, right, then you're gonna have a certain amount of intervals. So if this, let me highlight this. So if this were a boundary point, right? So this is a boundary point, this is a boundary point. What I like to think about is like an invisible line here separating my graph. And what I'm interested in this case, is where is my graph going to be negative, right? So what I do is we take some test points. Pick any points that you want. I would say be wise, make them nice, and we get to plug them into our calculator, or even if you do it by hand, it's not bad at all. So what I'm going to do is I'm going to plug a point to the left of -1, a point over here, any point that you want. So you could see that we plug in -2. So we plug in -2 into that original inequality. And what you're looking for is you're looking after the sign. Is the sign positive or negative? You don't care about the number. You just want to know, is the sign positive or negative? In this case, we get a positive sign. So what that means is that when I plug in -2, I'm going to get a positive answer. And actually, when you plug in any number to the left of -1, you're going to get a positive outcome. All right, so you know your graph is above the x-axis. If you plug in a number between -1 and 4/3, such as 0, right? If we plug in 0 here, this is 0, this is 0, you're left with a -4. So you're left with a negative answer. So any number between -1 and 4/3 is going to give you a negative answer. So that's what we're looking at. And that means that the graph, the height, is below the x-axis. All right, over here, we're plugging a number that's greater than 4/3. So we plug in 2 into our function, and we see that our outcome is positive. So we get a positive result. And again, I like to use a chart here and just plug in these numbers so I could see what those outcomes are. But again, I'm more interested in the sign. All right, and remember what we're looking for. We're looking for all the numbers that when I plug them in here, that will give me a negative answer. That's my solution, because I'm looking for the values that makes this inequality less than 0. That's what I'm looking for. So any number between -1 and 4/3, any number in this region, look, is going to give me a negative output. So that's why my solution is any number from -1 to 4/3. And so that's what I'm looking for right there. So again, the idea is huge. All right, that's technique number 1. Technique number 2 is first factor, right? So we're going to find the mother factors here. And so just like we did here, except what we're going to do now is we set up our table. And so we're just picking points, right? Just like we did on the left-hand side, the middle, and on the right-hand side. But instead of plugging it in directly to the original function, or sorry, this one right here, when one side is equal to 0, we're going to plug it into the factored form. So if I plug in, say, a -2, I could say, oh, when I plug in -2, this turns out to be negative. When I plug in -2 into here, it turns out to be negative as well. And because these two are being multiplied, a negative times a negative, my final outcome is a positive. So I'm paying attention to this side right here, right? And so some of you might find this technique easier. And again, it doesn't matter as long as it makes sense to you what you're doing. All right, so again, what I would plug in to this first factor is I'll plug in, say, 0. If I plug in 0, this gives me -4. So that's why this was negative. If I plug in 0 here, I get +1. So that's why I get a positive here. Again, I don't care about the numbers. I just am concerned about the sign. So a negative times a positive, that leaves us with a negative. And I know this is going to be part of my solution because, again, same thing. I want to know what interval, right? What numbers will give me an outcome that's less than 0. So it's key that you know what it is that you're looking for. All right, so let's do one from start to finish so you could see what techniques and what skills you're gonna need to master in order to be very successful in this section. All right, follow me. All right, folks, so let's solve this inequality. So let me walk you through to show you it's not bad at all. But you have to make sure that your factoring skills are sharp, and all those skills that we learned in the past, we're gonna bring them back, right? So let's go ahead and let's distribute this 2x. So we get 2x squared minus 2x is less than 21 minus x. So again, we want to set one side equal to 0. So we're going to go ahead and subtract 21 and add x to both sides, minus 21, and we're going to add x to both sides. All right, so let's go ahead and combine our like terms. And notice what we've done here. The only thing that we're doing is algebra. So we haven't done anything fancy. All we're doing is algebra. So the first step, right, there's nothing to it. Just make sure your algebra game is on point. All right, same thing, we need to factor this. So again, algebra. So most of what we're doing, right, is making sure that our algebra skills are, right, airtight. So let's factor this. So we need two numbers that are gonna multiply, give me 2x. So let's go with 2x times x. All right, two numbers that are gonna multiply, give me -27. Let's go with 7 and 1. I'm not gonna put any signs yet, but remember in my other video, a fast way to check is what we're gonna do is we're going to multiply 7 times 1, which is 7, and then 2 times, look at me, let me erase this part. It's 7 times 3 gives me 21, right? Because these two numbers right here, 7 times 3 have to give you 21. So again, we're gonna do the middle. 7 times 1 is 7, and then 2 times 3 gives us 6. So we have 7 and 6. Let me write this down so you could see what I'm talking about. So we have 7x, and then we got 6x, right? Is there some way that I could get a -1x? Well, absolutely. That's if we make the 7 negative and the 6 positive. All right, so those values right there, boom, work out perfectly. So those are my factors. So what I do now is I take each one of those factors, make some room over here, and this would be where I do scratch work. Some of you could do all this in your head, but what I'm gonna do is find my boundary points. I'm gonna set each one of these equal to 0. So we set these boundaries, or we find these boundaries by setting each of those factors equal to 0. So one of them is gonna be 7/2, right? We get 3.5. The other one's much easier. X plus 3 equals 0. Subtract 3 from both sides and you get -3. So those are my boundary points. And again, this is stuff, algebra. And I would do that on scratch paper. You don't need to show all this work, right? So we have our boundary points. So let's go ahead. And we have a boundary point at -3. We have another one at 3.5. All right, so now we just find our test points. And our test points, again, this is where you have the option. How do you want to do it? So I'm going to go ahead and plug in some nice numbers. So my test points, I'll do them in black here. I'm going to plug in -4. So my test point is going to be -4. And what I'm going to do is I'm going to plug it into either here or into my original function. I don't mind plugging into the original function, right? I'll let my calculator do the work, but even if you're not allowed to use the calculator, it's really easy. So let's just plug in the -4, and then you go ahead and plug it in with me, and let's see what you're getting. All right. So we get 15. Again, the only thing I care about is when I plug it in, I get a positive answer. All right, that's all I care about. I don't care what the number is. And again, look at what we're looking for. We're looking for the numbers that when I plug it in, give me something less than 0, a negative. So I know that this region is not going to be part of the solution. Let's continue with this process. So now I'm going to plug in a number between -3 and 3.5. Let me plug in 0, easiest number in the world. So when I plug in 0, no calculator needed, right? This goes away, plug in 0 here, this goes away. So you're left with -21. Again, you're left with the negative. That's all you care about. All right. And the last part, 3.5, let's pick something greater than 3.5. We're going to plug in 4. Plug in 4 into your original function. Let's go ahead and do that. And if you're interested in how to do this into your TI-84 in a fast way, or into your one of your apps that you've downloaded for free, I have videos of those apps. Just let us know, comment down below, and we'll be glad to show you how to do this fast on the calculator, right? And so you're left with a +7. All we care about is that it's positive, right? So again, then at the end, what you do is you look at which regions was I interested in, all right? So in this case, I was interested in the region that gave me something that was below 0, so this negative region. So your solution is that region right there. It's from -3 to 7/2. So our answer is from -3 to 7/2. So there is our solution, because that's the region, right, where if I were to graph this, I would see that that function lies below the x-axis. So any point between -3 and 3/2 that you plug back into this function is going to give you a negative, right? Gives you something less than 0, all right? Here's an additional note, right? This is bonus features right here. So let's say I wrote down or equal to 0. So if I said or equal to 0, then what you would do is you would actually include these endpoints right here, because if you were to plug in the -3, that would actually give you 0. So if they were to have a line right here and said or equal to 0, then what you would have is closed brackets, and that would change our solution. So what you have to pay attention to is make sure that you look and understand the inequality signs that they give you. All right, mathletes, so let's do one more, and let's make this one a little bit more challenging. Follow me. All right, mathletes, so let's look at this bad boy right here, because this one requires a little bit more work. So let's see what I'm talking about. All right, so we have an inequality, so we know we're going to set one side equal to 0. So let's go ahead, and for this one, let's subtract 8x squared, and let's add x cubed to both sides, minus 8x squared plus x cubed. All right, so we're going to get our right-hand side equal to 0. So we have x to the 4th, and let's put everything in descending order, plus x cubed minus 8x squared minus 12x. So I want to make sure we don't miss anything, and we have everything in descending order. All right, so now that we have one side is equal to 0, all right, so now what we're going to do is we're going to see how do we factor this. We have 4 terms. We would try factoring by grouping. Unfortunately, if we try the grouping method, it won't work here. We notice, right, the first thing when we talk about factoring is you always ask yourself, is there a GCF? Yes, there is, right? There's an x. So when I factor out the x, I'm left with x cubed plus x squared minus 8x minus 12. All right, so that's what we're left with when we factor out the x. All right, again, we already said that this I cannot factor by grouping. So then what you want to use is there's a bunch of techniques. You could use the rational zeros theorem. So the rational zeros theorem, we have a video linked down below. If you forgot how to use that, that's one option, right? And what that will do will give you a list of possible rational zeros. And then you would run through that list to find an actual 0. What I like doing, if you're allowed to use technology, is to actually graph this. And if you were to graph this, you could find one of your zeros that way, right? And so what we'll do is I'll look at the graph here, and I'll get my calculator to tell me that one of our zeros is 3, right? One of our zeros is 3. So what I'm going to use is I'm going to use that 0 to find potentially more zeros. All right, so here we go. I'm going to use that 0, and I'm going to use synthetic division here. And I'm going to use synthetic division. What that's going to allow me to do is factor this further if possible. All right, even if I can't factor it further, if I end up with a quadratic, I could use a quadratic formula to find the remaining zeros if they're real. All right, so let's go ahead and let's set this up using our factor theorem here. So let's go ahead, drop down the 1. So we drop down the 1. Let's make that arrow a little cleaner. So we get a 1. We know we multiply the 1 and the 3, and that gives us 3. We add those two, we get 4. We multiply 3 times 4, we get 12. We add those two, and we get positive 4. We multiply 3 times 4, and we get 12. All right. What's awesome is, notice this was x to the 3rd power. These were the coefficients. So when you use this, right, synthetic division, what's remaining is 1 degree less. So now this becomes the polynomial 1x squared plus 4x plus 4. And what's great about that, right, x squared plus 4x plus 4, is I could factor that, right? This factors nicely. So again, there's so many powerful tools, and the main thing when you're in any math class, because there's going to be so many ways to getting to the solution, is you really understanding when can I use all these theorems and properties and formulas, right? Because all that's garbage if you don't know when to use them. So make sure that when you learn a formula, when you learn a theorem, that you really know what it provides you with and when you could use it, right? Those are the two most powerful skills, right? Because it's just like a phone, right? Many people use phone to distract themselves, but what I want to encourage you is to use that to help yourself out, right? So again, math is great when you put it to use, and that's what I want to encourage you to do. All right, so let's go ahead and let's factor this bad boy. We get x plus 2 and x plus 2. All right, so we got x plus 2 squared. And notice we already have another factor. So let me write down all the factors that we have. So our factors, and don't forget we factored out the x to begin with, so we have the x hanging out. You have the x plus 2 squared because there's 2 of them. And then we have the x minus 3. All right, so when you factor this initial, right, polynomial here, this is what we're left with. And if you're wondering right now, wait, how in the world did he get x minus 3? Or remember, if 3 is a 0, right? If 3 is a 0, then x minus that 0 is a factor. All right, so one of our theorems, again, going back to, you really gotta make sure you understand those theorems. All right, so this is the most important part of this problem, because then the rest of it is easy. The rest of it, and this is where we have a challenge for you, right? We already did the bulk of the work here in Dr. Math Studios. Now we're gonna let you finish. So first, let's find the zeros. So the 0 for this, we set that equal to 0. We get x equals 0. We set x plus 2 equal to 0. Subtract 2 from both sides. You get x equals negative 2. And then x minus 3, set that equal to 0. Add 3 to both sides, and you get x equals 3, but we already knew that. All right, so notice, these are my boundary points. So now what you're gonna do, mathletes, all right, is you're gonna plug in a point to the left of negative 2. You're gonna check out that interval. You're gonna plug in a point between negative 2 and 0. Plug that into either the original function or right here in the factored form, and see if you get an answer that's positive or negative. Then you're gonna plug in a number between 0 and 3. Same thing. You're gonna see if the answer is positive or negative. Then you're gonna pick a number greater than 3. Then you're gonna see if the answer is positive or negative. So what we want you to do is comment down below, and we'll call this interval 1, we'll call this interval 2, interval 3, and interval 4. So plug in those numbers, and we want you to comment down below which one of those intervals, right, will provide you with the solution to what we're looking for. And remember, we're looking for something that's going to give us results that are greater than or equal to 0, right? So we're looking for positive answers. So plug in some numbers in these intervals, and what you're looking for is positive answers, or if they're equal to 0. So since they're equal to 0, what we're going to talk about next time is just make sure when you're writing your solutions that you're including, right? You're including those endpoints. All right, so let me just write down the possibilities. So from region A, it'll be from negative infinity to -2. We never reach infinity, so that's why it's always a parenthesis. Region B here, I'll do that in a different color, would be from -2 to 0. All right, that'd be region B. Region C here, I'm not saying that those are, just because I wrote it above and below doesn't mean I'm implying their answer is positive or negative. I just don't want them to be squished in here together. So region 3 here, C, is from 0 to 3. And then the last region, move this out of the way, is from 3 to infinity. All right, so what you're gonna type down below is which regions, A, B, C, or D, or what combinations is our solution. All right, mathletes. So again, hopefully this was very helpful. A lot to think about, right? This is a challenging topic, but again, with time, you got this. So hopefully you enjoyed this session, and we'll see you next time in Dr. Math Studios. Peace.